Rich Tehrani with TMC here. We're at CES 2012. And we've got one of the more innovative products that I've seen at this show. And we've got a guest who's going to talk about it. And his name is Brett Sharenow. He's with Switch Lighting. Brett, welcome to the show.
Thank you, Rich. Thanks for having me.
Our pleasure. So you've got a really interesting product. The viewers can think of it as the light bulb that crosses the divide between the promise of energy efficient lighting, but brings to the buyer many of the benefits of traditional lighting, the incandescent lighting, but at the same time with tremendous energy efficiency and none of the problems associated with some of the other technologies that have been used between, I guess, the incandescent and the LED phase of light evolution.
That's right, Rich. This is essentially a direct replacement for an incandescent light bulb. You go and take your incandescent out of the socket, screw this one in, and you're ready to go. This light bulb has the exact same color as a regular incandescent. It's got the same room-filling light. If you look at this shade here, you can see that the shade itself in the room is filled with light. The beauty of this light bulb, however, is that it saves 80% on energy over a standard incandescent and lasts about 25 times longer than a standard incandescent light bulb. So some huge advantages with no mercury, no contamination to the environment that you get from a standard compact fluorescent that have been out for the last 20 or so years.
Now, compact fluorescents promised in the early days that they were going to have unbelievable lifespans as well, 5 years or more, and that didn't come to pass. And I'm curious if you could tell us how this technology differs from that technology.
Sure. Compact fluorescents have within them a unit called a ballast, which converts the wall power to the power that drives the actual twisty part of the bulb. The problem is when compact fluorescents came out, they weren't tested well enough and they weren't put in situations where they would replace a normal incandescent light bulb. So if you take a compact fluorescent and put it in any application where it gets hot, the ballast in the base has a tendency to fail. And that's typically what causes a compact fluorescent to fail more quickly than it's normally supposed to. The other problem today with compact fluorescents is that they're quoted as lasting 8,000 to 10,000 hours, which they do if they're left on continuously. But if compact fluorescents are turned on and off, like are done in a standard residential application, their lifetime degrades significantly. So a standard lifetime of a compact fluorescent of 2,000 to 4,000 hours is pretty typical.
Now, well, we should actually just touch on the differences a little bit more. You've got liquid inside that bulb, and you've got some proprietary technology which keeps this device a lot cooler than other bulbs, or a lot cooler than it normally would be, and subsequently, because it runs cooler, the components don't burn out as quickly.
Right, so what we have in the side of this light bulb are 10 light-emitting diodes, or LEDs, and LEDs are semiconductor chips and they get hot. The key to producing the amount of light that we can produce, the brightness of a 60 or 75 watt equivalent light bulb, is to keep the LEDs themselves cool and the driver that's in the base cool. The way we do that is with a proprietary liquid that's inside the light bulb, and it acts just like the liquid that's used, for example, in your car radiator to cool the engine. That liquid brings the heat from the LEDs to the surface of the glass, and just like Thomas Edison designed this 130 years ago, our entire light bulb gets hot. So we dissipate heat not only from the aluminum area on the bottom, like everybody else who's making LED light bulbs, but also from the entire glass dome.
Right.
And the beauty of that then is the LEDs stay cooler, they can produce more light than anyone else, they last longer, in other words, they've got more reliability, and we also can provide that beautiful warm radial flux, that room-filling glow that you normally get out of a standard incandescent light bulb.
Now, this is really great technology. I can't wait to see it commercialized and available, and I'm curious, how did you get the idea? Where did this come from to start the company?
So the company was started by 5 founders. Their original concept was to take the LEDs that were just getting bright enough to do a normal standard incandescent light bulb, and they took the LEDs and put them inside of a baby food jar. The baby food jar was filled with a gel, very similar to Jell-O. And inside that gel were particles, these white particles of essentially white paint. And they were doing this for two reasons. Number one, they wanted to take the directionality of the LEDs that act like little flashlights and spread it out so they'd have a nice warm glow that you normally get from an incandescent light bulb. The second thing they were looking at that gel to do was to cool the LEDs. The initial bulb looked great. The gel didn't cool quite as well as the initial founders wanted it to. And we spent the next year and a half or so going through about 1,000 different types of fluids, very similar to the way Thomas Edison went through thousands of different types of filaments to develop his Edison bulb about 130 years ago. We settled on the fluid that's in here, actually a very benign liquid that's a food grade product. It's used in beer and pasta and women's cosmetics. It's low cost. It provides the cooling that we need. It dissipates heat very, very well, and it treats the LEDs beautifully so that this bulb will last the 25,000 hours that we're specifying on the package.
And it's an interesting design.
Yeah, the design essentially was done for a couple of reasons. When you look at standard lighting that's done today, we don't normally look at a light bulb in a fixture because it's too bright. What we wanted to do is come up with a very unique design that looked as good off as it does on. And one of the things that we're finding, customers are coming to us, and normally people have put in standard frosted types of light bulbs. This bulb happens to be clear, although we do sell it in a frosted version. The beauty is that clients are looking for this bulb to be in a socket and to be visible. So in hotels and restaurants and in homes, people are going to leave the bulb bare. And the reason is because it looks so beautiful in the off condition.
It is kind of a cool industrial look to it, right? Leading edge industrial kind of design. So
yes.
It's different.
Yeah, we had a very prominent design firm work with us on getting the industrial design to be as beautiful as it is.
Now, what about in other parts of the world that have different form factors for lighting? How do you address such issues? So
in the United States, we use 120 volts. Most of the rest of the world, it's 220 to 240. We're developing our light bulb for those markets right now. It'll be available in sample quantities for Europe and a variety of other countries that use that in the third quarter of 2012, and then in high volume to those markets in the fourth quarter of this year. The technology also lends itself to other form factors, as you said. This happens to be what's called an A-lamp, which is a standard bulb that we're used to. But because of the cooling technology, we can apply this to the globes, the fixtures that are normally used in bathrooms, to reflector lamps, those that are normally directional and used in ceiling cans, candelabras, and even those tiny, what are called MR16s that are used in a lot of track lighting that are very small.
Sure. The MR16s are great. I know interior designers love to use the MR16s.
Yeah, they like to use them for two reasons. One, they're very small, and two, they produce a color of light that's quite beautiful. It's more white than we're used to in a normal incandescent. We will be able to mimic the exact color temperature of that light as well with our switch lighting.
You see a lot of those bulbs in, if you go to high-end stores. If you go to high-end stores, you see them aiming at, the merchandise that the store wants to sell you or to showcase.
That is right. Because they're whiter, they have a tendency to make the item look better to the human eye. So you'll see them used a lot in retail. You'll see them used a lot for home environments where people are trying to show off artwork as well. Same reason.
Okay, now what about availability?
So we started shipping this product to the commercial marketplace about a month ago. We have it in 2 hotels right now. We'll be shipping higher volume commercial shipments next month. Continuing throughout this year, we're forecasting it'll be available to the retail market in the fourth quarter of 2012 for under $20.
Now, and we should, okay, so under $20, and it should have a shelf, or it should last somewhere, about how long will this bulb last?
So the bulb is spec'd to last 25,000 hours, and it's interesting the way LEDs work. They degrade in their brightness. In other words, their brightness goes down slightly every moment they're used. So the 25,000 hour point is still the point the bulb is considered good. After that, the bulb will still be illuminating. It will just be less bright than it was when it was originally sold. But 25,000 hours is our standard specification.
So really, unless the electronics burn out inside, it just keeps going. It's not like a filament or something like that.
That's correct.
That, you know, eventually just burns.
Right, not like a CFL or an incandescent where when the driver goes or when the filament breaks, the light goes out.
But there could still be an issue with the driver, theoretically. I mean, there could be a defect, or there could be in certain, like maybe in Arizona or something like that, where it gets really hot. I mean, are those some of the challenges that you might have to face?
One of the beauties about the driver is it's a proprietary technology that we developed. We had a senior power engineer who was an expert in power develop the driver for us, and it's been modified over the years. This driver's been taken through some very severe testing at high temperature, high humidity, and also low temperature, low humidity. So we're actually not forecasting any kind of failures of the driver with these.
Okay, it's worth pointing out that for those people that are interested in knowing such trivia, that the base of this actually looks like a heat sink. And if you open up a PC, at least in the last 10 years, they start putting these heat sinks on top of the chips, because this kind of fan-like pattern actually irradiates heat much more effectively. And so it kind of have like a minor heat sink built, actually it's all the way around, so it's a heat sink built into the base of it, which is really kind of cool. It looks good, and it also is functional.
Yes, it's exactly what it is. It is a heat sink. As you said, microprocessors and computers have heat sinks like that on them. And the aluminum is used because it's inexpensive. It conducts the heat away from, in this case, the base very, very well. And as you said, the striations that you see, or the fins, give it more surface area. It's designed for looks. It's designed to look good, but it also dissipates the heat more quickly than if it was flat.
So this question I kind of feel weird asking. You're trying to change the world and change every single light bulb in the entire universe. And I still have to ask you, what's next? So I'm going to ask you anyway, because I'm sure the viewers want to know, what else are you trying to do?
So if you take this light bulb and take it to the next step, this is what we call a digital light bulb. If you look at, for example, the old phonograph records, the 78s and 45s and 33s that we're used to, those went away and were turned into CDs, right? So now you've got a situation where we've taken the analog light bulb, the standard incandescent, and made it digital. So take this light bulb now, and you can put all different types of circuitry in it to do things going forward. For example, this could potentially be turned into a smoke detector with the light bulb, so that you could automatically have a fire sensing system in your house just by putting this light bulb in. The light bulb can be set up to be addressable, so that with a control panel, potentially on your iPad that's in front of you or over the phone, you could turn on or off the lights or dim them any place in your house that you wanted to. This could have a Wi-Fi component built in, where you had an internet port any place in your house. So take that whole digital concept and bring it into lighting, and that's what's next.
And that's really cool, because we're seeing that you know, one of the areas that TMC reports on quite often is the machine-to-machine space, and that is just the connected devices that are communicating with other connected devices. And you know, obviously the smart home space is one of the hot areas nowadays, especially at this event. And so really it all comes together with smart energy and smart grid and smart home and M2M and connected devices. And it'll be very interesting to see the kinds of things that you can do, like maybe turn these things on and off just from a, like you said, an iPad.
Well, we're incredibly excited. Those people that have driven the hybrid vehicles, and you've seen them on the road sometimes, the Priuses come to mind. People have a tendency to say, those drive very slowly. Well, they don't drive any more slow than regular cars, but they've got a little indicator on the dash that tells you what your miles per gallon are as you're driving along. And that affects human behavior,
Correct.
And people use the gas pedal or the accelerator more gingerly because of that. So imagine taking this light bulb and having an indicator up that's telling you how much energy you're actually using in your household.
Or you get an email if you're using a lot more than you know, whatever setting that you were thinking that you set that threshold. And I have a coworker that when he bought his Prius for the next 6 months, he told me that he would race himself every day, but not race in the traditional sense. He would, I guess, try to compete with his best fuel economy to the office.
I've heard that before.
And which personally, it's not something I would do, but I understand that people do that.
Yes.
And I think that's really interesting that you're pointing that out, that because now we have the opportunity to bring that same kind of technology to the whole smart home, and where we might look and say, oh wow, we're on track to increase our energy usage by 25% this month. Maybe we should just scale back and just remember to turn these lights off, or maybe we should have them all be at 50% brightness, or whatever other kinds of things we need to do in our home.
So take that to the next level and monetize it. So now put the light bulb in, put it on a dimmer, and instead of saying how much energy you're saving in terms of a percent, how about if we say this is how many cents you're saving per hour as you dim the light bulb down. So take this light bulb, dim it down to whatever you think you need to operate in that particular room, and then look at your savings.
And you can even budget it, and you can say that I don't want my electric bill to go over $100. I mean, everything will shut off at the end of the month if you go over. But that's a sick. We can try to plan that out so that we don't go over, I guess, right? Have all the devices shut down. And there's also other things that we're able to do as well, right? With the smart grid, as long as the information is, you don't even need a smart grid for this, but as long as you have the information available to the consumer, or at least to the bulb, or to something in the cloud that can talk with it, to let the bulb know when there's peak energy pricing and lower energy pricing, and maybe just dim 20-30% or something like that when the prices are high, and then
I could certainly see that. I could see the utilities using the data somehow in an anonymous way to plan out their utility needs for the coming days, weeks, months, years, and know exactly what they were going to have to do to handle demand over time. And as more and more of these types of products become deployed, and as more houses put switch bulbs in, probably a much better sense for what kind of deployment we need for both power and the infrastructure, transmission lines, to be able to handle the power requirements of various neighborhoods.
Yeah, I'm thinking of application after application. You can put motion sensors in these to shut them down when you're not in the room. I mean,
you
can just
thinking.
Go on
Yes.
and on and on. So it's really, really interesting.
Yeah.
Well, I hope you'll be back on the program. I hope we'll talk again soon. Congratulations on what seems to be a potential breakthrough product, and good luck.
Thank you very much. We're really, really excited for where this is going and what this is going to do to help change energy use throughout the world.